And with that, we will start with the introduction. So first of all, who is MISP and who is Circle.lu? So basically I'm part of Circle.lu. This is a department of LHC, which is Luxembourg House of Cybersecurity, and we are mandated by the Ministry of Economy to act as the CERT for the private sector in Luxembourg. And we are leading also the development of MISP as one of our duty. So in addition to leading the development, we also run multiple large MISP communities. I think we are running something between 20 and 30 communities. Some of them we are like heavily helping the community and setting it up, and others we are just acting like as a provider of the service. Yeah, and MISP project is basically a project that is an umbrella that covers many other projects. You will see a small diagram later on. All right, first, what is MISP? So MISP is a trade intelligence sharing platform, also called TIPS, that is totally free and open source software. So you can go on GitHub, you can grab the source code, you can install it, you can run it, you can provide the hosting service. I mean, it's open source, it's meant for that. And it's I think it's quite a major project that is fairly old, like it started in 2012. And you can see on the chart that the development has been going very well. So all the dots are basically releases that happened. So we don't have, I didn't updated the graph for 2025, but you can see that we have a nice stream of releases, which are mostly community driven, but we'll talk about that in a minute. So MISP is also used worldwide to manage trade information and do trade intelligence. And a lot of users really are using this tool to perform their daily activities. We have a lot of contributors as well. These are not only the contributor on the MISP core application that we will mostly talk about today, but this also takes into account contribution to other projects that the MISP project has under its umbrella. So in few words, what is MISP basically? So MISP is a tool. It's a tool it's a server that you can run or that you can have access to. And at the entry point, let's say, it basically collects information from various sources. It can be from your partners, it can be from feed vendors, it can be from your tools, it can be from your analysts, and so on. So it collects all of this information, and then it normalizes so that it's fairly easy for you to interact with it programmatically. Once this information is normalized, it improves that data by, for example, automatically creating correlation link, by enriching the data, filtering false positive, and so on. And once you have that enriched and normalized data, it allows team and users, colleagues, to collaborate on this data. And once you have that really well collaborated data that is normalized, correlated, enriched, and so on, then you can finally disseminate that data by feeding, for example, your protective tools like firewall, SIEM, IDS system, and so on. Or even sharing that data with other organizations through a synchronization process. We'll talk to that later. Oh, this is just a small diagram that shows you what we know about the public MISP exposed on the internet. This is on the left, and on the right side, you have the evolution of organization that ask to have access to one of our most popular MISP instance, public MISP instance, that we have also called MISPRIV. And so you can basically see that we have a steady stream of new organizations requesting to have access to this one. So if you want to have access to that public MISP instance meant for the private sector, do not hesitate to send an email to info@circle.lu and just basically ask access to our MISP instance for the private sector. So a lot of people are using MISP, but who are these people? And I mean, the communities that are using MISP are really broad and varied. At the top, we have like the private sector, like the financial institution, the manufacturing, the telecommunication, the banking sector. They are using MISP. We also have military organizations such as NATO, military CSIRT, even other CSIRT and governmental CSIRT. We also know about security vendors that are using MISP, some topical communities as well. And this was really interesting. One of the examples that we have is the one for the COVID-19 MISP instance that once the COVID-19 outbreak started, you may probably remember, but there was a lot of, how do we call that again? Like disinformation campaign. And so this specific community was really targeting that disinformation campaign, and they share all what they knew about. So it was really topical, and it was a really cool initiative. We also have ISACs that act as a sharing hub for various sectors, such as the telecom, the aviation sector, the retail sector, and so on, and many others, such as the law enforcement agencies or other international groups that you may be part of. For example, First.org is also a huge user of MISP. So a lot of different user profiles, which can lead to different expectation of what the application can do. So from the ground up, MISP has been designed to perform context-free threat intelligence, and it allows you to contextualize and curate your data through various mechanisms. You can enrich the information with context and metadata. You can gather the context from other services. You can map your threats and TTPs and see what techniques are threat actors using, at least the thing that you know about. It offers standard classification so that when you classify information, you can also so when you classify your information, you see what you are currently doing, but also when you get that information from partners, if everyone is using the same classification, everyone can understand each other. And so basically it uniformized the sharing of context. We'll talk a lot about that because it's a core component of MISP and it's extremely important, especially if you start to share data with other organizations. A lot of other features to provide curation of your data, to remove false positives, and to improve your data so that it becomes basically actionable so that you can immediately feed it to your predictive tools. And different visualization features that you can use to like view what is trending right now, and also to compile threat landscape reporting so that you have a complete view of everything that you know about. About the MISP project, because I talk a bit about MISP, I talk a bit about the MISP project. So let's talk a bit about that. So MISP, also called MISP Core, is the application that we'll be talking about mostly today. So this is the application that enables you to do everything I've explained so far. So the correlation part, the gathering data, the dissemination, the collaboration, and so on. But in addition to this application, we have many sub-applications or companion applications that integrate with MISP. For example, MISP module is an enrichment service that can run as a companion tool that offers to MISP or any other tool, because it's another application, a mean to perform enrichment of your data. By enrichment, I mean getting more information out of the information you provide. For example, if you have an IP address, you can get its geolocation. And to do that, we use this enrichment service to resolve the geolocation of that IP address. Another, this time it's not a tool, but it's a library. It's called PyMISP. So MISP has an extensive API, but to make it more practical, we also have developed a Python wrapper around that API so that you can use Python to interact with the application. Yeah, and we also have many other projects, but if you're curious or want to learn more, I invite you to go on the GitHub MISP project page and have a look at what's there. We have a lot of repositories over there. So that's the open source software branch. But you also have the intelligence and knowledge base branch, which contain the normalized classification that we have. So all the taxonomies and standardized vocabularies that you can use in the application, but also lists like the warning list that help you to really remove and flag common false positive. For example, if you have the file hash of an empty file, this is something that obviously is a false positive if you want to feed that to your SIM or IDS system. And typically, by using warning lists, you will be able to quickly detect and take action on this potential false positive. And the two last branch are more related to the standards, because we have also developed the MISP core format, which is also an open standard, and the MISP object template, which we'll describe and talk about a bit more later on. And the last branch, the intelligence and sharing communities, where basically contains all the document that we produce, such as the GDPR document that we have produced, the training intelligence best practices, the training document, and training materials that are also available publicly for free. And last but not least, the Circle MISP OSINT feed that provides like compile a lot of OSINT feed that we know about, compile that into one unique OSINT feed that you can, in few clicks, enable and gather in your own MISP instance. So I've talked a bit about synchronization. And just to give you an overview of what that actually means, this diagram shows a lot of MISP instances connected between each other. Well, it's not a full mesh, but at least it's a nice network topology. And basically, the whole idea is to show that one organization, such as Bank One, may receive some IOC or may experience an incident, and then they start sharing, and it can help other organizations that are completely unrelated to the first one. For example, if Bank One would have an incident, like they discover a new type of malware, or just simply share some malware configuration, then by sharing it through MISP to, for example, the financial ASAC that they are part of, it can flow through a national cert, which can then propagate information to cert for the health sector, which finally may end up in the MISP of a hospital. And then at that point, they would be able to feed that new information to their protective tools. So just by sharing information, you can see that it can really flow from totally unrelated sectors. So to continue about the sharing, we have in MISP a wide range of strategies to share information. So a lot of granularity that you can use. For example, you can describe that this data can only be visible to me, or that this data is visible to everyone, so it's totally public. You can also select some predefined list of organizations that you can give access to your data. You can also describe how that information should be synchronized to other MISP instances. We also have support of air-gapped system that is more for the military sector or the law enforcement sector, but that's something that is totally supported. Feed-wise, we have multiple formats that we can use to ingest information through various feeds. And in addition to ingesting data, you can also produce your own feed that can be ingested by other MISP instances. So that's very handy if you are like an ISAC or you want to produce a feed for customer. A lot of filters, caching. We'll not go through everything today. This requires like a 4-hour training to cover all the different synchronization and things that you can do in MISP. But basically, it gives you an idea on how complex how complex you can have of a synchronization setup if you want to, because things can be very simple, but if you want, it can be very complex with a lot of condition and logic in how the data gets synchronized and shared. All right, now regarding information quality. So We have also tons of features that allows you to curate your data. By curation, what I mean is remove false positive, get alerts if something matches something that you would expect, correlate your data, get information that someone else saw that information as well, enrich your data through the enrichment system that the MISP module service offer, workflow system that allows you to put automation inside MISP so that you don't have to create that automation outside of MISP using like scripts or API calls. A lot of integration with a plethora of tools. We'll show some of them today. API that allows you to write your curation pipeline if you wish to. A lot of organizations are already doing that. Yeah, and we could go all the way up to indicator lifecycle management, but that's not the objective of today's meeting. So to give you a simple curation process that most of organizations are doing nowadays, could be described as that diagram. So the square represents a MISP instance. And on the left, you have like a feed provider, which you could imagine it's simply a feed that you collect. And once it enters your MISP instance, automatically the correlation process will start, which will create automatically link to see if something has been seen in another incident. Then you will run the warning list to cull the false positive from commonly known false positive from your datasets. Then you can run enrichment to improve and enrich basically your data. Then you have the collaboration phase where you can have analysts like putting sightings on some IOCs, discussing about some malware configuration, requesting more information from partners, and so on and so forth. Then at the same time, you could run workflow to further improve the quality of the data or sanitize the data. That can also be used for that. And the last step would be publishing to actually disseminate the data to your productive tools, but also to other MISP instances and partners. So this is a really simple curation pipeline that a lot of organizations are doing nowadays, and it can be done fairly easily in MISP. So I've talked a bit about the MISP format, core format. And if you remember in the diagram, we had the MISP core format, but also the MISP object. So MISP object are basically a flexible data format that is supported in MISP that allows you to basically describe any concept that you would like. For example, you can describe an IP address, you can describe URLs, but you can describe things that are not, I would say, IT related. For example, cars, planes, credit card, passports, and so on and so forth. So it's very flexible. And the nice thing about this format is if a MISP instance knows about one of that MISP object and another one doesn't, when you share the data, then the other MISP instance that didn't know about it will learn about it and will be able to use it right away. So it's an efficient way to like describe and share any concept that you would like. We'll talk a lot more about the object later on because it's an essential component in MISP. Now, regarding integration, we also have many features and endpoints and tools to help you put in place automation. We have, as I mentioned, the API and PyMISP. So these are the main entry point to interact programmatically with the application. But you also have other channels, such as the publish subscribe channels. So you might know ZeroMQ or Kafka, but basically MISP can act as a producer of information, and you can have script or monitoring tools that subscribe to these channels and take action if they detect something that they should take action on. We also have the enrichment service and import and export module that are available through the MISP modules. For example, we have very good compatibility with STIX 1 and 2. And for that, we are using this import export through the MISP module. So we can import STIX 2 and convert it into the MISP core format, but we can also do it the other way around. So take the MISP core format and export it into STIX 2. And last but not least, we have a workflow system in place that allows you to quickly create really simple automation by just drag and dropping some blocks in the user interface, linking them together, entering the condition, and let the system take care of that automation step. Yeah, this is just a sample of a workflow and what it looks like in the user interface. So in addition of this workflow feature, we also have a blueprint library that you can have access to on GitHub. It's a list of a few workflow that you can quickly use in your application. I think so far we have around 15 blueprint or workflows basically that you can have a look at and use right away in your application. It's not much, but I think it's a good start if you want to use that system. Now, MISP is also called a thread sharing application, and sharing includes collaboration. And so we have a lot of features to help you collaborate in the same team, but also with other organizations. Just to name a few of these features, we have proposals that allows you to create change requests to data that you didn't create. So that if you notice that someone created data that you don't agree with, you can create a proposal and ask them to change that data. We also have analyst data, which allows analysts to create notes and opinion. I think I have a screenshot on the next slide to like discuss about some specific topic or just mention that something is very valuable to them, built in the user interface. We have a delegation system, but this is more for Isaac that offer pseudo-anonymity to the data and many other features that really help collaboration. And this is the screenshot I was talking about. So basically, you can attach these notes and opinion to anything we have in the application. For example, on an IOC, you could say that this IOC is very valuable to me, or this is a false positive that should be removed. You can also use it to ask things, like if you don't agree with something and you want to request like a malware configuration, you want to request more information about that specific IOC, that's the place where you would usually like ask these questions. All right, so how do you get started in this? So there are basically two branches. As a new user, you can join one of the existing MISP instance. So for example, I've mentioned the MISP community. So it's simple. You just send a mail request to get access. And if you got your access, then you can start using the application. Another one would be to host your own MISP instance. And so once you have your MISP instance running, you can start to synchronize and get data from other MISP instances. A typical case is organization setting up their own MISP instance, ask to have access to the MISP instance, and then they start a synchronization so that they have the same data that we have on MISP, but on their MISP instance. And at that point, they can start running queries, doing exports, putting the curation and automation in place without sharing anything with us, basically. And that's the typical use case. Now, there is the other one, and I think this one is, if we have at least one person today, that would be a driver, that would be really awesome. But it's basically to create a community and invite many organizations to join this community. So basically acting a bit like an Isaac. So typically, if you act as a driver, well, you have to first, and these are just like opinion or recommendation. First, you have to estimate the requirements and the objective of that community. Then you have to decide on some common vocabulary so that everyone understands each other and everyone use the same contextualization as the others. And finally, and this is the nice plus, if you want to offer services to your members, such as enrichment services like having access or giving access to various total APIs or running even curation on the data that your member create, that's a nice plus. And yeah, this is, we skip that and we'll go straight to what's really important right now to know about MISP is the future of MISP. So we have the medium term. So we released version 2.5, I think it's about a year ago. And that means that support for 2.4 is actually stopping in few days. So if you have installed a MISP instance and are still running on 2.4, I cannot recommend you enough to actually upgrade to version 2.5. It's extremely important because feature-wise, the development will be stopped for 2.4. Now, for security fixes, we might backport that also to 2.4 if we notice some on 2.5. But for how long, I cannot say right now. Now, for the long term, we are currently developing MISP version 3, which, as you will quickly realize, do a nice makeup of the user interface and aesthetics of the application, because it looks a bit outdated nowadays. And in addition to that user experience and user interface improvement, we want to put the analyst in a more centric place. So yeah, that's if you know a bit about the application. But if you don't, it doesn't really matter for you. Just know that we'll improve the application and continue to improve it for a long time now. Yeah, just this is not advertising, but basically we as Circle also offer professional services. So if you need a support contract, if you need training or hosting, you can get in touch with us. Just go have a look on the MISP project webpage and you will get all the information that you need. And that's basically it for the introduction. All right, so I saw a few questions and I would like to take them live. So could you see how MISP can be installed? Yeah, this I won't show, but Luciano pasted the install script and the documentation, which is good enough. Is it Mac friendly? So the recommended OS on which you should install MISP is Ubuntu, but we have also many other operating systems that you can use, especially if you like Docker. I mean, we offer a Docker image, and so basically it would run on any operating system that you would like. The requirement to use actually MISP is simply a browser, an updated browser, basically. Any IT for V3? This is a very good question and embarrassing because it's been in development for quite a while. But the thing is, we kind of did the trick of taking some feature that we developed for MISP 3 and put them into MISP 2.5. So yeah, for the user interface, this is definitely going for V3, but some of the concept that we wanted to have in V3 has been actually, some of them already moved into 2.5. And other are in development in both 3 and 5 and 2.5. Once again, the recording will be made available online on the training document, but also on the MISP project webpage. All right. Next up, general usage of the application. So if you want to have a look at what MISP actually looks like, once again, you can connect to this MISP training instance that is available. So I will share the credential in the chat for those who don't have access to the document. So you can take any user between 1 and 100 and use a provided password, and you can play with the application. You can create data, you can explore data that is already there. It's really meant for that, so do not hesitate. So I will show you what MISP looks like. So once you log in into MISP, this is what you will be greeted with, the event page. So the event page is basically the page that shows you all the events that have been created by your organization, but also any other organization. So right now we only see 9 events that have been created by Circle. These are simply test events that are there for you to like explore and to see what you can create. And if any one of you would create new events, we will see them appear on this page. So what is an event? Well, an event can be various things. An event is basically a container that regroups information that are contextually linked between each other. For example, if you have a ransomware attack or a ransomware incident, you would create one event and enter all the information you know about this attack or this incident inside that event. And that's it, basically. If you are browsing the web and you see a very interesting security blog post that describe a new threat actor or new malware variant, then you would create one event and describe all that information inside that event. So in MISP, we don't really have this notion of incident, blog post, and so on. Everything is an event. And then this event, you can decide to contextualize it into one of these categories. Right. So what do we have? What do we know about these events? So we have the creator of that event. So who created that information, basically. On the middle of the screen, we have all the context that we know about. So we can see we have some TTPs there. We see that during this incident or for that specific event, we have timestamp going on, symmetric cryptography, asymmetric cryptography. We see which sector was targeted. We see which regions were targeted. And we have more context about like releasability, the certainty of the information, and yeah, some other context. And then on the right side, we have the info field. This is basically the title of the event. So for this event, by reading the title, we know that this is a new malware that targets HPC infrastructure. What else do we have? We also have on this instance an event that talks about a ransomware attack against a French organization. And by looking at the context, we see that it's the malware Conti. We also have an investigation about the Syrian Electronic Army activity and a takeover via the Melbourne IT register. So we can see it's very varied. So let's have a look at one of these events and see what it looks like. So at the top, we basically have the same information than we had previously. So like, what is the title? Who created that information? A bit of context. The distribution of that event. We'll talk a lot about that later on, but basically who can view the data and how it can be synchronized. The published state of that event, so if it has been published or not, and some timestamp regarding the time it was first modified and the time it was last modified. If we scroll down, still more information about the context. Then a bit more down, we have the event reports. So event reports are simply reports that you can visualize immediately in the interface. So you can see it's an interactive report. We have some highlighting going on. If you click on some of the elements, it will show more information about it. You can also have pictures. You can click on some tags. You can click on the different MITRE attack techniques and get more information about them. So basically, it's an interactive report that you can have inside your event. And later on, all the interesting things. So like the meat of the event, the actual data. So on this event, we have information about some files. We have some file hashes. We have the target machines that were targeted by that malware. We have some cryptographic information. We have some pictures added as attachments. The link to the original blog post that was published in 2021. An IP port, and even a YARA rule. So that's great. All right, so I think that's not too bad to quickly explain the user interface. Now we'll talk a bit about the data model that we have in MISP. So this is how I like to view things. In MISP, you have two kind of layers. First one is the data layer, so the actual data that you have in your application. For example, I've mentioned the events, all the reports that would fall under that data layer category, and all the IOCs and supporting data, such as the IP addresses, the link to the blog post, the file hashes, and so on. All of these they fall under the data layer category. And then we have the context layer, which is the layer that classifies your information through tags. So this is how you can describe that an event is either an incident or a blog post, that an attribute has to do, or rather, let's say a file, has to do with a specific type of malware category or that specific type of malware, or that specific information should be shared with that releasability level, and so on and so forth. So we'll have a look at these two layers, starting first with the data layer. And we will start with the first one, which is the basic building block that we have in MISP, which are called MISP attributes, or simply attributes. So attributes, as you can see on the right side, this is what they look like in MISP. They're basically individual data point. So we have file name with that value. We have an IP source, so an IP address with that value. And we have an URL with that value. So see, it's really simple building block. So you can also have domain, you can also have link, you can also have file hashes. Attachments can also be an attribute. So it's basically the meat of what you are dealing with. Now, there is one thing that is important in MISP, is that these attributes, they have a flag that allows you to differentiate between an indicator, so something that you would like to put in your protective tools, and supportive data, also called observable. For example, if you would have this URL that is delivering malicious content, this is something that you want to put in your protective tools. So for that one, you would enable or check the IDS flag. So this is how we call that IDS flag. If you would have, for example, this IP address, and you know that this is a non-malicious IP address, then the IDS flag for this one would be disabled. So let me give you another example, which is the one that we use all the time. If you have a malware that tries to detect if it has internet connectivity by pinging 8888, which is the public DNS resolver of Google, and then if it succeeds, tries to download its configuration from a malicious URL, then this information you want to encode both in the event. Because from a SOC operator perspective, you are only interested in things to block. So you would only encode like the malicious URL. But from an analyst perspective or security researcher perspective, you want to know about all of this detail and behavior that the malwares take. So you want to actually describe both operations. So in MISP, what you will do, you will encode both the URL and the IP address 8888. But the difference between the two is for the URL, you will enable the IDS flag, stating that this URL is meant to protective tools. But for the 8888 IP address, you won't enable the IDS flag because it's not meant to be sent to protective tools. It's just unobservable. It's just supporting data. All right. We'll probably talk a bit more about that, but that's the main component. So what do you have to know about these attributes? Well, they're the most basic data point that contain data, and you can differentiate between IOCs and observable by the state of the IDS flag. Next up are MISP objects. So I've already talked about objects, telling you that this is a flexible data structure that allows you to describe any concept. And this is basically what you have on the screen. So on the right side, you have what an object looks like in MISP, and we are looking at a file object. So a file, know a file can have a file name. It can have many file hashes depending on the content of the file. A file also have a size in bytes, and you can also have the actual content of the file. So all of these entries, they are attributes, right? We saw that on the previous slide, like file name. All of these, they are attributes. But with an object, these attributes are grouped together. So to give you another example of objects, other example of object would be a person, a credit card, a domain IP, a device, a certificate, and so on. So basically, what is an object? An object is a templated composition of attributes that make sense together. That's it. Now, next, data structure. Oops. And this is the events. So we already talked about event. To recap, events regroup information that are contextually linked together. So you can use them to encode incident, to encode blog post, to encode report, to encode that something happened, like an event. And these events, as you saw previously, they can contain, they contain many elements such as the attributes, the objects, and the event reports. All right. Now, one last little thing. You see that you can attach context on the event. So we saw in the user interface that you can attach context on the event, but you can also attach context on the attribute themselves. I don't have any other tags for these ones. But what is important to remember is that any context that you attach on the event layer also propagates onto the lower level, basically. So if you attach TLP white or TLP clear to the event, automatically all the attributes will also inherit that tag, so that TLP white tag. That means if you're trying to export all IP addresses that are tagged with TLP clear or TLP white, you don't need to attach this tag on the attribute level. Just adding it to the event level will make sure that all of these attributes contained within that event will be exported. And I think this is the last piece in the data layer is the event report. Basically, event reports are simple reports that you can use to describe processes, to describe behaviors in a human readable form. And these event reports, they are Markdown aware. So basically your report, you will mark it in Markdown. But the Markdown syntax has been improved to support a special syntax that allows you to reference entities that exist inside a MISP event. For example, that file, fix.zip, is a file that exists inside a MISP event. And you can see that you can create a reference using that special syntax inside the report to create that link. And so once you create that link, this makes the element interactive. So you can click on it, see the tags attached to it, and so on and so forth. So you basically transform a static report into a dynamic one. Because since this is a reference, if anything would change inside these objects that we have there, they would change also in the report as well, since they are dynamically linked. Analyst data, we already talked about it quickly. It allows analysts to attach notes, opinion, and relationship to basically anything that we have in MISP. And as an example, we have this note and opinion attached to an IP address, so an attribute of type IP address. And we say that there is a long comment and that the same user, it's kind of weird to have it like this example, but it could be, we could imagine that that would be another user would say that they strongly agree with the analysis and that this IOC is actually a true positive because they have seen that IP address somewhere. All right, so let's have a quick look at the context layer. So now we know everything that we need to know about the data layer, so how to encode information. But now let's have a look at how to classify that information. And just to cut short the chase, in MISP, anything that touches to context, behind the scene, it's a tag. So it's simply a label that you attach to your data. But these labels, they come from different sources. We have the free tags, which can be created by any user. We have the taxonomies. So this is a normalized classification, basically, that allows everyone to use the same vocabulary. And we have the galaxies, which are also normalized classification, but they are closer to like a dictionary or an encyclopedia than the taxonomies. So let's have a look at these three. And we'll first start with the free tags. And immediately we'll realize why we don't really recommend to use free tag nowadays. It's because as anyone can create them, giving too much flexibility to a user can also sometimes lead to unexpected behaviors, such as the one displayed on the picture on the right side. If you give a mean to user to be creative, they will be creative. And so in this example, they basically wrote in different ways the same concept. So for a user, like an analyst, if you read these TLP Ember tags, you know what it means. But for a machine, this is more tricky, especially if you want to export data that is tagged TLP Ember. How would you do it? You would have to find all the data and all the different ways that TLP Ember is marked, or you could use something like substring searches. But if you use substring searches, you probably know that this will induce more costly operation on the server side. So you're better off not to use substring when you can. So yeah, it can really make automation and sometimes understanding difficult to use free tags. So we'll quickly move on the next one, which solves that issue, which is taxonomies. So as mentioned previously, taxonomies, they are a standardized set of vocabularies that are, first of all, globally understood because it's normalized and it's used everywhere and it's available right away to everyone. And second, it really is consumption by human, but also by tools, allowing you to put in place automation. Like now, if nobody would use all this tag and everyone would use this TLP Ember tag, it becomes straightforward to just export any data that is tagged with TLP Ember because there is only one way that TLP Ember is written. Next up, we talk about taxonomies. Now let's talk quickly about galaxies and galaxy clusters. So galaxies, you can view them a bit like an encyclopedia that contain a collection of clusters. Like I will give you an example with country. So in MISP, we have the MISP galaxy called country. And in this country galaxy, we have a cluster called Luxembourg. But we also have a cluster called Belgium. We also have a cluster called Germany. We also have a cluster called China. So you see, we have basically all the countries inside that cluster, that galaxy country. But like the Luxembourg country cluster has more than just its name. It also has and described the possible TLDs that Luxembourg has, the language spoken, the currency used, the population, and so on and so forth. So you can see that you can describe really in depth this item belonging to this collection. Now, another example which is way more complex than a country would be Tradactors. So on the screen, you have the Tradactor galaxy with the APT29 galaxy cluster. So APT29, we know a lot of things about it. We know the potential states that is sponsoring that Tradactor. We know the potential victims or suspected victim of the Tradactors. We can also have the documentation pointing to more information about that redactor. We also have all the synonyms that we know about that redactor. For example, I think Cozy Bear is one of these synonyms. And knowing about these synonyms is important because when you receive feed from different sources and they use different redactor names, you want to be able to reconcile that data. And so knowing about these synonyms really helps us to normalize that data to ease consumption. So in addition to all of this data, we also have a way to create relationship between different clusters. Like I took a very small sample that shows you that the redactor APT29 that we're currently viewing has a relationship saying that it is similar to another redactor called APT29G0016 from another galaxy, which is called the MITRE Enterprise Attack Intrusion Set galaxy. But we also have in MISP the which TTPs, like which techniques or even which tools do redactor use. For example, you have APT29 that uses these techniques, that uses these tools, and so on and so forth. And we have that as relationship. All right, quick table to differentiate between galaxies and taxonomies. Both of them are normalized classification. On the left side, taxonomies, they are self-explanatory and mostly used for categorization. On the other side, the galaxies, they are typically, as they are encyclopedia, they describe high-level information and provide a lot more of contextual information when you attach them. And you have a few examples. For example, on the left side for taxonomies, TLP, so Traffic Light Protocol, and PAP, Permissible Action Protocols, are typically taxonomies. We have taxonomies to describe false positives and confidence in these false positives. And on the right side, to give also other example for galaxies, like the country that was mentioned, the redactor that was also mentioned, but also very important one, the MITRE attack galaxy, which is basically the MITRE attack framework that has been converted into MISP galaxy so that you can use that framework inside MISP. All right, that I will keep for later. Right, I think that was a lot of talking. So what I will do just before the break, because I like to do short breaks, is to give you the link to have it as favorites, is the link to the cheat sheet that we have. I will share it in the chat. So basically, we have this MISP concept cheat sheet that describe a lot of complicated concept that we have in the application, such as publishing. What does it mean? What is the difference between pooling and pushing? What is a synchronization filtering rule? What is a correlation engine? So you will find information on that cheat sheet. A quick reminder or explanation on how the distribution works in MISP. Don't worry, we'll cover that later on. Same for the synchronization. And then what we just seen right now, the different data model and data structure that allows you to encode information. So we describe the event, attribute, objects, taxonomies, galaxies, and so on and so forth. And at the end, we have the user and admin cheat sheet. On the left side, the user cheat sheet with common API calls and API queries that you can use in the application. And on the right side, some comment meant for admins, such as the most important one, resetting the root password if you forgot it. Also how to update your MISP instance, how to change settings, and so on. All right. So we'll do now a 15-minute breaks to allow you to get, if you want some coffee or some water, so that you have time to take that. So we'll start again at so in it's not 15, but closer than 10 minutes. So at 3:15 CEST. See you in 10 minutes. Welcome back. So now, next on the agenda is a small walkthrough on how you would encode data in MISP. And to do so, if you scroll down, you can also have access to the small demo encoding that I will be doing. So it's also another training document. So if you click on this link, you will be shown this web page, which contains all the data that I will be using for that demo. So for that demo, you can do two things. Either you try to do the encoding at the same time as I'm doing it so that you get some hands-on experience before the actual exercise, or you just sit back and relax and watch me do. All right. So let's have a look at what we are dealing with. So this is a fake spear phishing example. And this is the context you are given. So we are basically a CSERT and we receive a message from another CSERT basically. And this other CSERT tells us the following. So we have had a failed spear phishing attempt targeting our CEO with the following details. So the CEO received an email that contained a personalized message, blah, blah, blah. So it's really targeted spear phishing. And the attacker pretended to be working for the school of the CEO daughter, sending the mail from a spoofed address. And so we have the spoofed address. They're also telling us that John Doe is the teacher of the student, so the teacher of the CEO's daughter, and that this email was received from this domain name, throwawayemailprovider.com, which at the time resolved to that IP address. Then they continue by saying that the email address they received, so the spear phishing email address, contained a malicious file. Find it attached. And so the malicious file has been added in the document there. And this malicious file, once it gets executed, it tries to download a secondary payload, this one, from that URL. So this URL at the time was resolving to that IP address. And then they tried to execute this in a sandbox, and they saw that the malware sample is trying to exploit that CV. And that also, after a brief triage and analysis, this secondary payload, it has an R-coded C2, so a command and control at that URL, which at the time was resolving to that IP address. And finally, they closed the mail by saying that this C2 is also acting as a collector for local credentials. So the malware is basically exfiltrating local credential to that C2. And they close the mail by saying that this is how far they've gotten into the analysis. And so they are telling you that it's still an ongoing investigation. And they ask you that they would like to avoid informing the attacker of the detection. So you can only use the content information to protect your constituent and not share that information with other services. So, or not scan back the attacker infrastructure, basically. So what we have to do first is to encode all of this data and then classify it with accurate context that would describe what these different components are, like if this is a malware, if this is a C2 server, and so on, but also to make sure that we contextualize the information to convey that we shouldn't like share broadly or publicly all of this information, and also that this information should only be used to protect your constituent. All right, so let's get started. So once again, if you want to do it at the same time, do not hesitate to log in that MISP instance and try to do the encoding. So first thing to do is to create an event, because we are going to encode an incident or to encode information that we receive from somewhere. So the starting point is basically to create an event. So to create an event, you have to click on this Add Event button on the left. Then you have this very simple form that asks you for information. So you can put the date, you can put the distribution. We'll come back to what all of this means. So for now, we'll just keep it with org only. it means that only your organization can view the data, so that anyone else cannot see the data, and that data won't be synchronized with other MISP instances. So it's like creating a private event, basically. Then you have these two fields, thread level and analysis. So these are historical fields that we cannot get rid of. So we are stuck with that. But usually this information, you attach tags from taxonomies to more accurately describe the thread level and the analysis. Extended event, we will leave that empty. And the event info is basically the title of that event. So it has to be concise and self-explanatory. So for that one, I will use phase per phishing incident. You hit submit, and there you go. You have your event created. So right now we have a bunch of warnings. We have warning that we don't have any content. We'll fix that. We have a warning that we don't have context attached to that event, that it's not good. We will fix that as well. And the last warning that we have is that we don't have data. Please fix that. And obviously we will do. So let's get started and let's start to add information. So what do we have first? And we start with something simple. It is that domain and that IP address. So what I could do is to create two attributes. First, to create an attribute of type domain, with that domain, and then create an attribute of type IP address with that IP address. But if I do that, you will see that I might have an issue later on, because I also have an URL which has a domain there with an IP address and another IP address. And so if I encode everything as attributes, I will just have a table that contains tons of attributes, and I wouldn't be able to tell to which attribute this IP address belongs to. Like, I wouldn't be able to tell that this one is linked to this one and not this one. All right, so to do that, simple ways to use object. So with object, you basically regroup attributes that make sense together. So we have domain, we have an IP. What kind of object could we use? Well, we could use the object called domain IP. So how do you add an object? On the left sidebar, you have the add object button. You click on this one, and then you have a drop down where you have to select the category in which your object is in. To be fair, I never know in which category objects are, so I'll always pick all object and I just search for the object I'm looking for. So I want to add a domain IP. I just type domain, and I see I have domain IP object. I click on this one, and there we go. We can create a domain IP object. Now you can see this is a huge form with a lot of fields. We don't have to fill everything. The only thing that we have to fill is the field that meets the requirements. And the requirement is basically this. To be valid, my domain IP object must have an IP or a domain or a host name. And it's a good thing because we have an IP and a domain. So we have basically two of the requirements fulfilled. So we can create a valid object. So let's do that. We have the domain. So I will just put the domain. I could put the host name. I have an IP address. And that's basically it. So that looks good to me. I can click on submit. If I click on submit, I get one last chance to modify my object. Everything looks good, so I can create my object. And that's it. Now, if I scroll down, you can see that I've created my object. Great. Now, what's next? Next is our URL there and IP address. So I will start with just the URL. I could just create an attribute of type URL, but then I wouldn't be able to say that, okay, this attribute relates to that attribute. So what I will do once again is to create an object. So to create an object, click on Add Object. You select all object and then you search for URL, because this time we want to encode more than just a domain. We want to encode the complete URL. You click on URL, and this time we can see the form is way bigger. So what we do, we look at the requirement. And what is the requirement for this URL object? Well, you have to provide either the URL or the resource path. And good thing, because we have both. So let's put the URL first. There we go. Credential we don't have. Domain. This time I could put the domain. I don't have to, but it's good to do. I could put the domain without tilde, but I won't do this. I could put the IP. I have an IP, so I can take it. Put it there. Do we have a port? No, we don't. Do we have a query string? We don't. Do we have a resource path? We do. It's always good to have, like, when you encode an URL, to have at least the domain and the resource path set. For correlation purposes, it's the way to go. We could also choose to put a scheme, but I will not do it this time. You hit submit. You look one last time if everything is okay. It looks okay. And you click on create new object. All right. That's a second object created. Next up, what do we have? We have the CVE. I will keep that for later. We have another URL with another IP address. So once again, I could create two attributes, but I won't do it. I will simply create an object because it's faster and it organizes my data intrinsically. So add object, all object, URL. I put the URL. You can put the port or not, up to you to decide. But you also have a port below there. So if you want, you could put it there as well. The domain. For correlation purposes, always good to put a domain. The IP. We don't want to lose this information, of course. Do we have a query string? No. Do we have a resource path? No. We have a scheme, but I won't do it. That's it. Submit. One last chance to review the information. This looks good. I can click on create new object, and there we go. That's not too bad. Huh? And what else do we have left? We have the two malware samples and the email that was sent. Even though we don't have much information about the original email, like the spear phishing email, we just know about the sender and maybe the display name and the domain from which it was sent, basically. We don't have the content, we don't have the subject, we don't have any headers, but we can create this email also. All right, so since we are at it, let's create that email. So we'll take the email address. No, I could create like one to two attributes. But I mean, objects are the way to go. So let's search for email. We have email. What do we need? At least one of these. So the from is enough, and from display name is enough as well. So that's perfect for our use case. Return path, we don't have any. We don't have any. We don't have the subject. That's a shame. We don't have a to. We don't even know the email address of the CEO. So that's too bad. To display name, no, we don't. From domain, this one actually we do. We can put there. Then from, we have the from, that was the spoofed email address. And we will assume that the display name is simply John Doe. And all the others, we don't have anything. So that looks good. It's a domain, not an URL. I don't know why I put like this, but it's okay. Let's quickly fix that. Oops. Obviously, this is not a valid. There we go. this looks good. Let's create it. There we go. We have our email. Now we only have three things to actually encode: the two malware sample and the CV. And we'll start with the malware sample. So for the malware sample, I could go on add object, select file, and then file, and fill out all of this form, which is quite big. But there is a better way to do it. Better and simpler way to do it. The trick is to use add attachment. So if we click on add attachment, you have this way simpler form where you can choose the distribution of the attachment that you will add a contextual comment. For example, we could say that this is the initial payload received by email. Then we can provide the file. So I can simply take the file. Sometimes it works, sometimes it doesn't. Samples, where are my samples? Go. Choose. And then I have these two checkboxes. The first one specifically tells MISP that we are currently encoding a malware sample. So if it's checked by default, and it's important to always like double check the status of this checkbox. If you are encoding a malware sample, you have to make sure that this is checked. Why? Because MISP will do additional processing once it gets the attachment. First, it will compute the different file hashes for that file so that you don't have to do it yourself. It will also create more information, for example, the size in bytes. It will automatically add the file name for that file and so on. And all of these attributes, it will merge them inside one object so that you have everything well contained and defined. And the last step, and it's written in bracket, it will also encrypt the file, so the actual payload. So it will encrypt and zip it so that if by mistake you download that malware sample, you don't get it executed on your system. Like you have first to provide a password to decrypt that archive, and then you will be able to like play with the payload. So that looked good. Let's click upload. And there we go. You can see that we have automatically created an object. We have the malware sample. We have the file name. We have 3 file hashes and the size in byte. All right, let's add the second malware sample. You go on add attachment. You select the second malware sample. You can add a contextual comment. You make sure that the is malware sample is checked, and you hit upload. There you go. We have our 2 malware samples. Now there is one last thing that we still need to do, is to encode the CVE. For this one, instead of using an object, I will simply encode it as an attribute so that you see how you can create an attribute manually, but also because it will give me the opportunity later on to perform an enrichment so that you can see how we can use the enrichment system in MISP to get more information about existing data. So to add an attribute, you click on the Add Attribute button. Then you have a form that you can fill once again. So right now we are trying to encode a CVE. So basically we are encoding something that is from an external analysis of type, this is a vulnerability. You put the CVE. You could put a contextual comment if you want. In this form, you can create multiple attributes at once if you do something like this and you check the batch import. But since you only have one, you can simply leave it as is. If you remember the whole discussion that we had at the beginning with the IDS flag, like the automation flag or the flag that allows you to distinguish between an indicator and an observable, the famous 2 IDS flag, this is the checkbox for that IDS flag for intrusion detection system. This is just a reference to a CV ID, so there is no need to check that. And that's it. You hit submit. And there we go. We have our CVE created. All right. That looks pretty good. Let's see if I have everything. Yeah, that's great. Next, we have created our events. We have encoded a lot of information, but we are not done. We still need to contextualize our information because right now it's really tough for anyone to consume that information. Like you would see from the list of events that we have, where is mine? There. That we have some spear phishing going on, but you don't know about the releasability with TLP. You don't know what you can do with the data with PAP. You don't know that we are, well, you know that you are dealing with spear phishing, but you don't know really what kind of phishing was involved, what were the TTP used, and so on and so forth. So let's add all of this information. And first, we'll start with tags from taxonomies. So I've mentioned TLP, so let's start with that. So you can see that first we have two buttons to add tags. We have what we call simple tags or global tags, and the other one called local tags. So usually, most of the time, you will create what we call simple tags or global tags. These tags, they behave exactly like you would expect. If you attach a tag and you synchronize that information, that event or that attribute, the tag will be carried along with the data. So if I add a TLP using the global tag, if I synchronize this information to other MISP instances, they will also receive that TLP tag. Now for local tags, these tags stays local on your instance. That means you can attach them, but they won't be synchronized to other MISP instances. Now you might be wondering, why would I want to attach a local tag? Well, there are many use cases, but most of them have to do with either automation, like if you want to add a tag to, I don't know, reprocess an event or to pass an event to a curation pipeline script or to synchronize with other MISP instances, things like that. So basically to automate or to have some kind of workflow built in based on tag. That's one of the typical use cases. Another use case is to be able to tag event or data that you don't own. So right now, if you received an event from someone else, since you are not the creator, you cannot modify that data. But if you are the owner of your MISP instance, like if you are the organization that hosts the MISP server, you will be able to attach a local tag to this data. So it allows you to really add more context, add more information to data that you don't own, basically. So as an analyst, most of the time you want, when you classify or you contextualize your data, you want this information to be synchronized with everyone else. So that's why we are going to use local tag, global tag, or simply tags. So back to our TLP. I will search for the TLP taxonomy. Then I can see all the TLP tags. And based on what was described in this exercise, they ask us to only use the information to protect our constituent. So based on that and the context, I can extrapolate and say that basically they are setting this information as TLP Ember. We could discuss if it's TLP Ember Streak, or TLP Green. That's not the point of the exercise. I choose TLP Ember and I'm fine with it, and I think it's a good fit. Now, what else do we have? Well, they also ask us to not inform the attacker of the detection. That means, basically, do not scan back the attacker infrastructure. How can we convey this information? Well, we have a similar protocol than TLP. So TLP is all about releasability, but there is another one called PAP. PAP is about what you can do with the data, so about permissibility. So let's have a look at the two ends of the spectrum. PAP white basically means no restriction in using this information. So if you tag something with PAP white, well, the receiver, well, when they see that, they can use it as they wish. On the other hand, we have PAP red. This is a bit more longer, it's more restrictive. If you see data with PAP red, that means the following. You can only use non-detectable action only. The recipient may not use PAP red information on the network, only passive action on logs that are not detectable from the outside. So basically, you cannot even share with virus total, you cannot scan back, you cannot put network filters if you receive something PAP red. Now, that's definitely not what we want to use this time because you still want to be protected. So let's have a look at PAP Ember. Passive cross-check. Recipient may use PAP Ember information for conducting online check using service provided by third parties or set up monitoring honeypot. This seems like a good fit. Same for PAP Green. Recipient may use PAP information to ping the target, blocking commit traffic. Ping the target. This is not valid because we don't want to inform the attacker. So let's take PAP Ember. All right. Now, what could we add like context? So what else do we have at hand? We have a taxonomy about phishing. So I think it makes sense to add more information about the phishing we're currently dealing with. So we have fake website. Was a fake website used? No. Email spoofing, that was definitely used. That was the vector, the initial vector. It was a spoofed mail from a spoofed email address. So we can use this one. What else do we have? Clone? No. Spear phishing. Spear phishing was involved. So we can take this one. Manual reporting. The spear phishing was reported manually by a CSERT. So we could also say specify this. You can even like report the origin. So it's not one of these. Could even say action, like if we need takedown, if it's pending law enforcement request, we can also specify the state of that spear phishing, the psychological acceptability, principle of persuasion. So it's a fairly complete taxonomy, but I think for practical, by practicality, I think these three are good enough. That's not too bad. So what else could we also include? Estimative language. This is just to give you like more example of what you could also add as classification. You could also add classification about the likelihood probability that this information is valid, or even the confidence in analytic judgment. So if you think that the judge that the confidence in their judgment is high, you can put high. And if you think that the likelihood that this actually happened as it's described is very likely, then you can also put it like this. All right. Now, let's move on to the galaxies. So it's not described in the exact size, but if we would imagine that this target, well, this attack was targeting the telecommunication sector in Luxembourg, we could describe this. So I could add a new galaxy. So first you have to select the namespace in which the galaxy is in. Once again, I never know, so I'll always pick home namespace, and then I pick the galaxy I want to use. Right now, I want to describe the fact that the telecommunication sector is a target. So I will use the sector galaxy, and I will pick one of these items from the sector galaxy. So we are looking at telecommunication. So you see we have telecoms, but you also have the synonym telecommunications. So if I were to search for telecommunication, you can see that even though the actual value is telecoms, I still get the telecommunication results. And this is pretty handy, especially when you're dealing with threat actors. If you're used to one way of calling a threat actor, and it's not the same as MISP, well, the root key that MISP uses for that redactor, then you will still be able to get the correct one thanks to the support of synonyms. All right, that was quite easy to add the telecommunication sector. Now, what else can I say? I mentioned that Luxembourg was a target, so I could also describe that. So there are two ways. Either I use the country galaxy, or I can also use the target information. And target information is slightly more precise because it's a galaxy meant to describe the target of trade actors. And in this one, we also have all the countries. So I could use one of the two, but I think target information is more accurate because when you will look at the event, you will immediately see that, okay, the target is Luxembourg. All right. What else can I add? The most important ones, the TTPs. So if I take home namespace, I can use the Mitre attack pattern framework. If you're used to the matrix visualization of Mitre attack, you can use the matrix. But for me, I'm not that used to this one. I prefer to simply use a drop-down to search for information. So I will just click on the small list icon that we have inside the build there. So we have some phishing going on. So I could select phishing. I could select spear phishing messages with malicious attachment. That's exactly what's going on. I could select spear phishing. Notice that we also support sub-techniques from the Atrium attack framework. I'll just use one of them. And yeah, that's not too bad. So I could already submit that. What else do we have? We also have a C2 server involved. So what do we have with C2? We have, this is perfect, exfiltration over asymmetric encrypted non-C2 protocol, or exfiltration over symmetric encrypted non-C2 protocol, exfiltration over C2 channels. This is exactly what's going on, right? Because the secondary payload exfiltrates local credential to the C2 server. So I could pick filtration over C2 channel. All right. So usually you would spend time putting all the techniques that you know about, but to make things move a little bit, because you are slightly running out of time for that text section, we'll move on to the next one. We've contextualized the envelope, so the event, but you can also contextualize actually the attribute themselves. And what I want to do is simply to mark that this URL is actually a C2 server to which exfiltration is going on. So this, I will just take that IP to find it on the page. This is the URL. So what I can do is simply go on this globe icon to add a tag. And this time I will add a tag from the adversary taxonomy. So the adversary allows you to describe different things related to the adversary infrastructure, the adversary action that you are currently doing against them, the state of the infrastructure, if it's up or down, the type of infrastructure, if it's a proxy, a VPN, a drop zone, an exploitation distribution point, or in that case, a C2. See, that's great. And we could also say that exfiltration is going on for this one, like automated exfiltration or exfiltration over C2 channel. All right. And the other one that I want to add is the distribution point, because this URL is used as a distribution point. So I could also add for the adversary taxonomy that this is an exploit distribution point. All right. That's not too bad. Huh? Now, to explain a bit about the enrichment service, this is the reason why I created this attribute. And you can see that we have this, this small magnifying glass that if we click on it, we'll get information about that CV. So we have that CV and some references and so on. But this is good. But what if I want to embed this information inside my event? Well, it's pretty easy. Instead of clicking on the magnifying glass, you scroll all the way to the left, and you can click on Add Enrichment, this small asterisk icon. Then you can choose which enrichment module you want to run against that attribute. And I will use the CV Advanced because it contains way more information. And interesting. I have, did a mistake. I didn't take the CV. That's the CV. Oh, come on. Ah, okay. I thought that was coming from CV Advanced, but it's not. It's simply coming from CV. So let's take CV. There we go. All right. So you see this enrichment actually creates a vulnerability object with a lot more information. So I can click on Submit, wait a few seconds, reload the page, and now we have our vulnerability created. Awesome. Now, to have a complete event, we still need to do two things. First, we could write a small report. For example, I could add, perfect, the email that was received from the partner about that case, and I could put the content of the email. So for example, I could put the whole email, can hit submit, and now we have the original email that was sent. What I could also do is to add another event and say, for example, executive summary of that incident, and then describe that what happened, like initial payload executed, secondary payload downloaded, and so on and so forth. So you basically describe in a concise way what happens in this event. So that's one thing that you could do and that you are encouraged to do, because for analysts, when they will look at this event, well, what they see basically is a list of files, URLs, and IP addresses, but they don't know the whole story behind it. So one way to convey the story is simply to create an event report. But there is also another way, is to use a graph to encode the relationship that you would have between the entities. So let's have a look at how you can do that. If you click on the event graph, it will show you basically all the entities that we have in this event and how they are related to each other. Right now, we just have that attribute CV and that vulnerability object that we created through the enrichment. And this one says that this vulnerability is related to that attribute. We don't have any other attribute there, but we still have 6 unreferenced subjects. So if I expand this, we can finally see the 2 payloads, the domain IP that was used to send the mail, the email that was sent, the URL that was used to download the secondary payload, and the URL of the C2 server. So what we can do is to create the relationship between these different entities. So first thing that we could do is to say that this email, so you can, to interact with it, you can either click on edit and then draw the arrow, or simply press the shift key to switch into the edit mode. That's the fastest way. So if you press shift, click on the first node and drop it on the second node, then you can create that relationship. So what we want to express is that this mail was, I would like to use received from. I will keep it and I will show you how you can add it if you don't have it in the list at the end. So let's keep it for now. what else could we say? Well, the secondary payload was downloaded from the first one. So we could say that the first payload actually downloads the second one. So we could say downloads, have it, but we can also say that it was downloaded from. So you can choose the direction in which you want to create these links. I mean, it's up to you to decide. You can do one, you can do both. What else? Well, downloaded from, yeah. This one was also downloaded from that URL. Maybe that was more accurate. Maybe downloads from would be more accurate, but anyway. And this secondary payload also exfiltrate data to the C2 server. So we could say that it exfiltrates too. Right? Now we still have these two. And we could say that this one, the first payload, was received in the mail or was included in the mail, or that it was, do we have included in? So this one, let's say, do we have sent to, sent, serves? So we could add one of these. And now I will show you the trick to create one relationship that doesn't exist yet. So to do that, is included? Included didn't exist. Okay. So I will use the receive from. So you see, receive from doesn't exist. But we can use the trick to select the custom relationship type. And if you select the custom, then you can type the custom relationship that you want to use. It's a small trick. So one of the reasons why it's a bit hidden is to force you to use one of these types. But sometimes there are none that like fit for what you want to express. And so you can simply create your own like this. All right, and the last one that I want to do is to say that the secondary payload actually exploit that vulnerability. All right, now what do we have? We have a nice graph that shows us like, the whole story of what happened. So I don't even need to read the event report. I can just look at it, see that you have two files. One of the files was included in one email that was received from that email provider. That file downloads the secondary one. This one was downloaded to that location and exfiltrated to that location. And it's actually not this one. It's actually this one that exploits that vulnerability. And that's basically it. That's not too bad. So now we have created a complete event with context, actionable information, graph that tells a story, basically, and event report. What else can we see on that event? We can see that we have a related event. So basically correlations. Correlations simply means that someone has encoded information in their event that match with ours. And if we look at the related event, we can see that it's struggling with the controls, that this malware sample was created in these two events. So if we click on one of these events, we pivot, and we can see that one of you, user 66, created that fail spear phishing incident, added some context, and added basically almost everything I did so far. So good job in doing that. And we can see that many of you actually created and did the exercise along with me. So it's cool to see. Right. All right. Before going on the break, I want to quickly show you a few things, like how to get the most out of your data. And for that, we'll look at 5 different things. How to search for data, how correlation is working in MISP, how to use warning lists to reduce the amount of false positive you have in the system, and finally touch about distribution and synchronization. So let's start with searches. So there are two, let's say, scope on which you can search for data. The first one is on the event itself. Like you could search on the title of that event, on the context that is attached on the event, on the creator of that event. You can also add searches on like the date at which something was created. Or you could search on the actual value of the attribute, like an IP address, an URL, and so on. But first, we'll have a look at how to search for events. To search for an event, you have to go on the event page, and then you have this magnifying glass on the top left of the table. If you click on this button, you can specify many rules, and with the query builder that we have, we can build the rule to filter this event index. So the first thing that we could do is, for example, say that we want to get all events that have in their title phishing. We can add that. What else could we say? We could say that I want to see all events that are tagged with TLP Ember, but that are not tagged with TLP Red. And you can see the query builder does it correctly. So we can see that the tag is TLP Ember and not TLP Red. And finally, I can see and select that all the events should be from the organization org main. This is the organization of the user account you are using right now. Once you have that, you can see that you have this URL that is created. You can bookmark it or whatever, but you can also click on apply and it will filter the index based on that. You can see that there is an active filter in place right next to the magnifying glass, and it like provides you a quick summary of of all the filtering rules that are active. Right. So that's how you search for event. Now, how do you search for attribute value? First, I will take one value, and that will be, let's take that IP address. And to search for an attribute, on the left sidebar, you have the search attribute button. You click on search attribute, you also have a form that allows you to search for it. And the one that you will probably use most of the time is the first entry, which allows you to simply search for one or many values at once. So let's give it a try. Let's just search for that IP. You click on search, and then you see all the events. You can see the event ID in this column that contain that IP address. So we can see that we have many events that were created by different organizations, namely org main and org name. All right. What else can we do with that form? We can also search for tags. Like you could search for any attribute that are tagged with TLP Ember of type, let's take SHA-1. So if we do the search, we have all the attributes that are of type SHA-1 tagged with TLP Ember. So if I look at this one, because you see we don't have the tag, right? But if I look inside this event, we can see the attribute. We don't see it tagged with TLP Ember, right? But if you remember what I said at the beginning, if you attach a tag on the envelopes on the event, it will propagate to its attributes. So if you have a look at the event, we can effectively see that TLP Ember is attached to the event. All right. What else can we do? We can also say that we don't want to see tag that are, well, attribute that are tagged with TLP Ember, simply by putting the exclamation mark in front of the tag name. So if we do that, we'll get all the attributes that are not tagged with TLP member that are of type SHA-1. And finally, we can also use substring searches. If you want to see attributes that are tagged with TLP something, you just put the person character, you hit search, and you will get basically all attributes of type SHA-1 that are tagged with a TLP tag. All right. So you can search on type, category. You can also search and filter if it's either an observable or an IOC based on the value or state of the IDS flag. That's up to you to decide. Okay. Next is enrichment, but that we already saw how it works. So enrichment, you can click on this add enrichment button. But if you want to enrich an event all at once, you can also, and I will take one of my events, you can also, on the event, click on enrich event. That will execute the enrichment module that you select in this drop-down list on all attributes that are eligible. Like if we want to use I don't know, DNS on this one, you click on enrich, and we have a small error there. Probably misconfigure training instance. I'm not that worried about that because I've been playing a lot with the configuration. But basically, you would have something that works, and you would have the DNS module run on all these attributes, right? Next, warning list. We don't have any warning on this one, so let's create one. So I will add an attribute, specifically 8888, and I will make the IDS flag enable for this one. Now, right away, you can see that we have a huge red box that says that we have some potential false positive in that event. And if we click on it, on this list, it will filter the attribute page to only contain the one that have false positive warnings. We can see which warning list was enabled. It's list of known IPv4 public DNS resolver. And we can see next to the attribute value that this attribute, 8888, is part of the list of known IPv4 public DNS resolver. And the reason why we have this warning is, first, the warning list is active on our MISP instance, and second, the IDS flag is checked. So definitely this is not something that you want to put in, for example, your firewall or your SIEM. So definitely the IDS flag should be disabled for that attribute. Now that we've disabled it, you can see that the warning disappeared, both on the event, but also on the attribute. All right, so warning list. Let's have a quick look at what is available. We have 87 warning lists. So we have the public DNS resolver Google. We have some Cisco umbrella blog page. We have a list of Wikimedia address ranges. We have names of top 10 most used sites, Tor exit nodes, known sinkholes, SMTP sending IP ranges, the local CIDR blocks, and so on and so forth. So we have a lot of them. And to enable them is pretty straightforward. You just click the enable button or the play button, and it will work. Now, something else that you can do is to create your own warning list. For example, this one contains the value 1, 2, 3, 4. So if you want, you can also create your own warning list with the value that should be marked as potential false positive. You specify the type of attribute that should match against this warning list. And once you have it enabled, your system will automatically warn you that you have created data that is part of a warning list. So if I try to add this one, you can see that I have a warning, my warning list, because this IP address is part of the warning list that I just created. So if you ever share data and you know about your infrastructure, like all your servers, IP ranges that you are running and so on, I don't think it's a bad idea to create a warning list out of it to make sure that you're not sharing internal details that could appear if you have, for example, sandbox execution or network captures, and that you're not sharing this potentially sensitive information, or at least information that would be seen as false positive. All right, last step is a small discussion about distribution and synchronization. And for that, I will take this slide. So you might have noticed that MISP has multiple distribution settings. The first one and the one we used so far is called organization only. That means when you create data, only your user and your organization can view the data. So it won't be synchronized and only your organization can see it, basically. The next level is called this community. And what it means when you select this distribution level is your organization can view the data, and any other organization on this server can view the data as well, but it won't be synchronized with other MISP instances. So right now, this fail spear phishing incident that I created, I use the distribution your org only. So if you look at the list of events, you will see all the other events created by all the users in this meeting. But this one in particular, so mine, you won't be able to see it because it's set to org only. So what I will do is I will simply change the distribution of my event to this community only. And now if you check on the event page, you will be able to see my event. But remember, it won't be synchronized to other MISP instances. That's the purpose of the two next distribution settings: connected communities and all communities. Connected communities means the same than this community. So anyone that have access to the server can see the data. But any connected MISP server will be able to get that data as well. So if we have a small diagram, if the square boxes are MISP instances, and we are publishing data set with the distribution setting connected communities from the gray MISP instance, it will be allowed, like any user on the gray MISP instance can view the data, and it will be allowed to be synchronized to the connected MISP instances. So that means the red and the yellow one, but not further, because it's only the connected communities. So if you want to basically not limit the propagation of your event, in that case, you would take all communities. So if we go back to the diagram, if instead of connected communities, you take all communities, it means that the data will propagate on all MISP instances that are connected through chaining, like one by one after the other, from the first one. So just to recap about all communities, if you select data with all communities, it doesn't mean that it's going to go public on the internet or that all MISP instances will receive the data. No, it just means that all MISP instances from the same network topology based on the synchronization link will receive the data. And the last distribution setting called sharing group. Basically, sharing groups, it's a distribution list that allows you to select who, based on the organization, who can view the data. And so in this example sharing group, that is banking sector in Europe, we can see that we have the training organization, we have a Hungarian bank, IFB, Italian bank, and CLN, and only these 5 organizations can view the data that is under the banking sector in Europe sharing group. So to give one last example about sharing group using that diagram, if we create an event with the blue sharing group as defined above, you see the blue sharing group contain these 4 organizations, but not these 2 below in black. So if you use the blue sharing group for that event, only these 4 organizations will be able to view the data. All right. I hope that was clear. I saw a lot of questions, but I also saw many replies from my colleagues. So I think everything has been covered. Now, next on the agenda is a break. But since I want to make sure that everyone has the opportunity to actually do the small hands-on exercise, I will do it right now. And for the people that want to go on break during the exercise, feel free to do. And the one that want to work on it and actually finish the exercise, well, you have the possibility to choose what you want to do. All right, so hands-on exercise. Let's go back to the training document. This is not it. Okay. So you can see on the document that we have encoding exercise, ransomware infection via email. And if you click on the link, you will be directed to the full exercise. So it's a more complete and complex example than the fail spear phishing demo encoding that I did, but I think it's good for practice. So what you have to do basically is redo what I did previously. So we have a small incident there that is about a ransomware infection via email. So you have a small chronology of the event, splash message, the evidence that were collected from that incident, and the type of data that was extracted from that incident, and finally the data that you actually have to encode. So that means the ransomware email. This time we have the full email, the ransomware malware sample, some IP address, some registry keys, 2 cryptographic keys, Bitcoin address, and a person. And then you have the task. So basically what you have to do for that exercise. The first and most important one is to create an event that must at least contain the keyword ransomware in its title. This is extremely important. So once you have that, you can get started to encode all the information. So what I will do while you are doing this encoding, I will be monitoring what you are doing, take some notes, and then give you feedback if it's needed, because sometimes I see a lot of good events that don't even need to have feedback. But I will give feedback to your events, so to provide recommendation. If something was really wrong, tells you that you did something wrong and why it's wrong and how you should do it instead, and so on. And so that will take around, 30 to 40 minutes, depending on how active you are. So if nobody is working after 15 minutes, we'll just cut it short. I will show the final results and we'll move on the next topic if we have time. Otherwise, as long as you are active, working on the exercise, well, I will let you work on it and do the correction at the end. So how to access the exercise once again. I will paste the URL in the chat, but you can also access it through the training document that we have there. If you scroll down, we have this section called hands-on exercise, and you can have access to the player document. Just click on exercise document, and we'll be able to see your progress. So this is how to access the exercise and how to access the training instance on which to do the exercise. Well, this is the URL. You take one username between 1 and 100 with the following passwords, and then you can start doing the exercise. All right, let's see. This is how I will be monitoring you. And I can see that one user already created an event, user 87. You were the first one. Congrats. And now since it will be mostly silent while you are doing the exercise, I will pause the recording and we will continue for the recording for the review. And now for the actual feedback about all the event you created. So based on the amount of event that was created, so we have 31 players. I won't get to all event, of course. I will just mention some points or raise some issue that I saw in most of the events. So the first one, and it's more a recommendation than anything, is if you have just one attribute, like just one unique IP address, it's better to use an object rather than just adding it as a raw attribute. And the main reason is because in future, you might want to add more information about that, like multiple IPs, a port, or maybe a domain name. And so you would have the object already prepared. And the second is you cannot create a relationship in the event graph with attributes. You have to use or you have to start from an object. So yeah, I would say using object compared to attributes is a no-brainer 99% of the time. There are few use cases where it actually makes like sense to use attributes. Like if you use an event like a list of attributes, for example, all IPs being targeted of things like this. But most of the time, it's better to use an object to describe anything. Now, I also saw in few events, still about object, the usage of the wrong object template, like this one. So instead of using the email object, I saw many of you use the FTM email. FTM stands for follow the money. And I mean, sometimes it makes sense, but I think it would have been better to use just the email object, the raw email object. So you just need to watch out when you create an object, not to take the first one that appear in the drop down, but to actually read the description, because sometimes they can be misleading, or they might not represent the concept that you want to describe. Another one, still about the encoding, is about the victims. So I don't have an event ID like this, so I will just take a random and hope it contains the victim information. Yes, this one. This is perfect. So encoding the actual victim or like suspect, whatever, makes sense in some cases. For example, the email source would make sense, but personal information such as first name, last name, roles, or if you have more information like the address of the person and so on, that's something that you shouldn't share broadly, in my opinion. I mean, it depends on the community, of course, but I mean, broadly in the sense of like for everyone in the private sector, because this is probably a suspect, but it's also probably a victim. So you don't want to disclose that. So what you can do is actually to restrict the distribution of some of these attributes, or even restrict the distribution of the entire object by just changing the distribution setting to something more restrictive. So you could say that this whole person object should be only visible to your organization, or that, for example, the role of that person should only be visible to your organization. So MISP offers you a lot of granularity on what you can do when it comes to distributions. Next one, and it's just something minor, but just would like to mention it again. We have this event which contains two nice things that is interesting to talk about. And the first one is the cryptographic material that I saw. Where was it? This one. So it's great to encode it in the event. It's really nice. But using other end text makes it harder to export or to automate things with it. So if you try to export this public key using the API, it will be tough to like really say that you want to get all public key from MISP because they are under the text type. So it's kind of tough. So the better way to do it would to be to use an object, especially the crypto material object. This one allows you to like express a lot of crypto components, anything relating to public key, private key, like pre-shared key, XOR key, and so on. So in this case, putting the public key in the public field is nice. And for the XOR key that was provided in the exercise, you could have put it in the generic symmetric key and select, where is it, the type, and select the XOR there. So that is a very good way to encode cryptographic material. Now, still on event 257, I saw something that was awesome, and it is this event IQL queries. So this is awesome to see, but it would have been better to encode it in a way that could be exported more easily. And we have a dedicated object to encode such kind of queries, which is called simply query. So the description of that template is an object describing a query along with its format. So you could use for the format EQL, and then you could have put the query there. And to export this information, it makes it way easier to deal with. And on the same line of thought, if you have something else than a query, but for example, a rule like Suricata rule, Yara rule, we also have dedicated object for that. Like for example, for Yara rules, you have a Yara object. For Suricata, we have Suricata object. And for something more broader, such as a script, you also have the script object that allows you to select the language. For example, if you have a Python script, and you can provide either the Python file or directly the script in the box there. Now, I also saw some event that created a file to contain the malware sample. So they created a file manually. A better way to do it is to go through the add attachment endpoint so that you can put the file, make sure that it's that the isMalware sample is checked so that your file is encrypted and hashed, and you get all the information you need. It's the best way to encode attachment. Now we'll go back on the main page and also mention that some of you used a free tag. Remember, free tags are tags that are not part of a taxonomy, so they are not normalized. The ransomware tag is a free tag. And usually it's not a good way to, well, it's not advised to use free tags. Using tags from a taxonomy is the better way to do, like it was done for this event. So just watch out when you are tagging and make sure that you use tag from taxonomies. Next one is TTPs. So we can see many of you added some TTPs, but not like these two. These two were added, but many other events didn't add any TTPs or context whatsoever. Yeah, it's extremely important to add that because you can get stats out of it. You can see thread landscape reporting. You can see the technique that you are covering and detecting, and the area where you are lacking detection or mitigation. For automation, it's also way easier to deal with things. So really, if you have to invest time in contextualization, it's a part of the context that you should really add. And that's also probably one of the reasons why many of you didn't get the contextualization task completed. Because to have this task completed, you have to provide 3 TTPs. So this one wouldn't have validated, this one no, because you have to have 3 from the Maitre attack. But this one, totally fine because it has more than 3 from the attack pattern matrix. All right, and last but not least, publish. That's something we haven't talked about. But basically, once you have finalized your event, you have to review the distribution. So to make sure that the people you want being able to see your event can do. Like this community is fine, but if it would be in your organization, you have to change the distribution so that you can actually share the data with people. And so once you have updated the distribution, you have to publish your event. And publishing, it does multiple things. The most important one is it starts the synchronization process so that this event will be shared to other MISP instances. Second, it will also expose the data to some export format. If you try to export this event as a Suricata rule or I don't know, Bro, Yara rules, whatever, any rules meant for productive tools, the data contained in events that are not published won't be included. So if you want to have all of this nice IOC in your result set, the event must be published. And last but not least, it also sends notification email to anyone that subscribes to notification email. How do you publish? It's easy. You have the publish event button on the left. So let's publish this one. You can even see which server will receive the event once it is published. You click on yes. You wait for a few seconds. You reload the page, and then you can see that your event is published. So yeah, not many. Oh, no, it's better. Some of you published it in the meantime. And I see that user 87 managed to also get them all, and I guess he or she was missing the contextualization one. All right. So that's it. We didn't have time to see an overview of the API and PyMISP. So what I will do instead is link to you the 2 Jupyter notebook that shows you a complete example on how you can interact with the API and the thing you can do with it. I'm going to share it in the chat. The first link is regarding the MISP REST API, and the second one is for PyMISP, so how you can use the Python library to interact with MISP. And with that, let's see if you have any pending question. So is there a complete example of this that we can compare how various indicators should have been added so we can compare with our own? Very good. And I will provide you a potential solution. So the one I did, but I think having a look at the event of user that actually managed to complete the exercise. So user 87, user 41, user 66 and 69 were also quite good. So I invite you to have a look at that. But I will also import the solution of that exercise into the instance. And to find out which event is the solution, I will leave it as an exercise for you. Just know that the creator organization will be org name. So you will have to use what you've learned on how to filter the event index to find the solution. All right. Last comment regarding the recording. Yes, it will definitely be shared. So do not hesitate to come back and check in the training document or also to check on the MISP project website. All right. I hope it was useful for you, and I wish you a good day. Thank you very much for attending. Thank you very much for playing the game with the exercise, and see you soon. Bye-bye.